All right, welcome to section 8.1. In this section, we're going to be dealing with interest. And interest is quite frankly a subject that is near and dear to all of our hearts and pocketbooks. Because if we have student loans, we should definitely know how interest works. If we have borrowed money from the bank, we should know how interest works. So if anything out of this entire semester that you really kind of pick up on, I really ask that you kind of learn interest and how it can affect you and it can affect your personal finance. All right, so interest, we know this basically, here's the official version. Money paid from the borrower to a lender for the use of the lender's money. Let's simplify that. If you borrow money from somebody, they're going to want more money back. So if you borrow $100 from me, I'm saying, okay, you can borrow $100 from me, but you have to pay me back $110. Well, that $10 is the interest. It is just a way of the lender making money. Okay. Principal is the money that's being loaned. Well, that's easy enough. It's the money that you start with. Okay. Another way I really like looking at principal is what I like to call present money. It's the money that you may owe or the money that you are investing in at the present time. All right. Interest rate. Interest rate is a percentage on which the principal will increase. We've heard this, you hear this all the time. Buy this car at 5.6 APR. What that means is annual percent rate. Okay, that's really what's happening. When you go to purchase something, and you want a low interest rate, you do not want to go buy a car that has an annual interest rate of 10%. If you do, you need to get your head examined. The lower your interest rate, the better you are. The reason for it is simply this. If you go to buy a vehicle or you are borrowing money from the bank and you have a high interest rate, it means that you have to pay back more money than you really should. Okay, so you're always you want a low. So the next thing is the future value. It's the total amount of money after the life of a loan. Okay, prime example, and you don't have to write this down, but I bought, the car, my very first car, I think if I'm not mistaken, it was maybe about $14,000. And I made payments on this particular car, and I made it over several years. By the time, and of course I missed payments, but that's another story. But by the time I actually had paid that car off, I had actually put in, and I think I'm telling you right, about $19,000. This was how much my car was actually worth. This is how much I actually paid because of interest rates and because of missing my bills and everything else. I paid $5,000 more for that car than what it actually was originally worth. All right, and that's what happens. That's what future value is. This is your principal, and your future value is wherever it might lend. All right, so this is some basic words and definitions that you're probably already used to, and more than likely because you've heard it in your life. However, let's add some math magic, and what we end up getting are two equations, and what we call these two equations are simple interest equations. We have I equals PRT, and then A equals P times 1 plus RT. All right, now let's start with this one. I like to call this I is pretty. You do why I like to call it I is pretty? Because I is pretty. I really am. I think I'm a pretty looking dude. So I is pretty. Well, I is pretty is simple interest. I represents the interest. This is how much you would be paying your loan, your lender, excuse me. P represents the principal. It's the money that you're starting with or your present money. R represents the interest rate. That's how much the bank may be charging you, 5% APR, 10% APR, etc., etc. And T, now this is important. Notice T, it says time in years. This is a big thing. When you are calculating interest, the time is always in years. Okay, you always have to put T as years. All right, so that's just I is pretty. Now, this one, well, I'm sorry, let me go back to this one. What I'm doing in this problem is just calculating the interest to owe. So a while ago, I gave the example, like if you borrowed $100 from me and you have to pay me back 110. Well, what you've just that $10 extra is the interest. So $10 would have been the interest for that particular example. Now this one, on the other hand, is dealing with what we call future value, or what I like to call the after money. All right, P is for present, A is for after. All right, so what I would do is I would put all the things in these equations, and I'm going to find out how much I actually owe the bank afterwards. So going back to my simple example I was talking about a while ago, you borrow 100 from me and I give you an interest rate, and at a certain time frame, that means that after that time frame is up, you owe me $110. Okay, that's what's happening here. Now this might be a little bit better explained by using some going ahead and getting into the problems. So let's do it. It says find simple, let me zoom out just a little bit for you. There you go, you can see that a little bit better. It says find simple interest, and then it gives me the principal is 500, the rate is 13%, and the time is 2 years. So what I'm going to use, since I know my principal, my rate, and my time, and I'm looking for simple interest, it's telling me I'm only going to be able to use one or two equations. I'm either going to use I is pretty, or I'm going to use A equals P1 plus RT. Now, look at what it gave me. It gave me P, it gave me R, and it gave me T. It didn't give me anything else. So this gave me PRT, and I'm looking for interest. While this one gave me, if I look at that, it's just PRT, but this one supplies me with future value. That's how you can tell which equation you need to use. This one is asking for interest right here in this problem, while this equation is asking for helps you solve for the after money. So that's how you can kind of flip-flop. Hopefully I made that clear enough for you to understand. So going back to it, this is what we're doing, and I'm going to use this equation. I is pretty. And I'm going to plug in all my numbers. I'm going to say my principal is 500. Now, rate. You have to remember this all the way back in Module 1. Remember what I told you about percentages. You always have to move your butt. So when I go to put this into my equation, I have to move my butt and change this to a decimal. So it's going to be 0.13. If you don't remember how to go from here to here, go back and review that from Module 1. I'm not going to cover that right now. Alright, so I is pretty, so P is 500, R is 0.13, and my time in years is 2. Well, all I really have to do is say this now. Put it in my handy dandy calculator. I'm going to clear this out. I'm going to go 500 times 0.13 times 2, and I find out that my interest is 130. And that's my answer. So at the end of this loan, I'm going to owe the bank an addition $130. Okay, that's not just paying them the beginning 500, but I owe them that additional interest of 130. All right, look at this one. If the simple interest on $7,000 for 7 years is $3,920, what is the rate? Okay, so we need to read this problem. What's happening here? So first off, we already understand the question, what is the rate? So that's what we're looking for. We're looking for rate. Let's look at some other things that are really easy to understand. It tells me 7 years. Okay, so that's my time. So I'm going to write that down, 7 years. Then it says this, if the simple interest on $7,000 is $39.20. So what's happening here is it's really saying that the simple interest is $39.20. So my interest is $39.20. But it's also saying that the interest was on $7,000. Well, that $7,000 happens to be my principal. Now I have everything I need to do. I know my principal, I know what I is, I know which is my interest, I know what time is, which is 7 years. I'm trying to find R. Well, which one of those equations will help me? Well, I is pretty again. Why? Because this question has nothing to do with after money. It's just talking about interest, and it's talking about the principal. So now that I have my equation, I'm going to plug all these numbers in. My I happens to be 3,920. My principal is 7,000. My R, I'm going to leave over here, okay? Well, no, I'm going to put it right here. I'll move it. And my other item is time, which happens to be 7 years. So my interest is $39.20. My principal is 7,000. I don't know what my R is. And my T is 7 years. So let's rewrite this to something that we can easily understand. So I'm going to say 7,000 times 7,000 times 7 gives me 49,000 R. So now I'm still going to solve for R. So what I'm going to do is I'm going to divide by R on both sides. Okay, and since I'm running out of room, I'm going to write it like this. I'm going to divide by the 49,000 on both sides. Okay, and I'm going to do it right here. Okay, running out of room on my paper. So 3920 divided by the 49,000 gets me 0.08. So I found out that 0.8 is my R. But here's the thing. If you put this down, this would be incorrect. All right, 0.08. This is not my answer. It's wanting a percentage. Well, this is a decimal. Just like I talked about back in Module 1. If you have not moved your butt, you have not done anything. So really, my rate, my APR that I'm looking for is actually going to be 8%. That's the answer that I'm looking for. All right, let's move on to the next one. Use simple interest to find the missing value. It gives me I have P, I have R, and I'm missing T. So I'm going to use I is pretty again. This time I'm not going to write I is pretty. I know I happens to be the 1280 equals P happens to be 8,000. My rate is 8%, so I'm going to change that to a decimal, 0.08, and I am trying to find out what T is. So I'm going to simplify this, and I'm going to say 8,000 times 0.8. So 8,000 times 0.08, and I get 640. So 1280 equals 640 T. I am going to divide by 640 on both sides. And when I do, I get 1280 divide by 640, and I get 2. So my missing piece was 2 years equals my time. Oh, sorry, didn't realize I got crooked on you. Let's try the next one. And again, it goes without saying, please pause the video as you see fit. I am moving through these pretty quickly for the sake of time. Next problem. A student borrows $2,000 on a 5%, a student borrows $2,000 on, this should say at. That should say at. A student borrows $2,000 at 5% for 3 months to pay tuition. Find the total amount due using simple interest. All right, so we're looking, now look at what it says. This time it says find the total amount due. Well, this is actually our after money, okay? So we're actually going to be using this equation. So let's write that down. A is equal to my principal times 1 plus my rate times my time. Okay? So, let's plug in what we know. A student borrows $2,000. All right, so that's going to be my principal. I'm going to go ahead and put my 1 plus there. And it says that I have a rate of 5%. So I'm going to put 0.05 for 3. What does it say? This time it says, I wish I had a different color here to highlight this. It says 3 months. What did I tell you at the very beginning, near the very beginning of this video? That when you do time, you always have to have it in years. The problem that we have is that this problem is telling me 3 months. Well, that's not a big deal. Ask yourself, how many months are in a year? Well, we know that there are 12 months to a year. So we can do a very simple conversion. And I can just simply say this. I'm going to do some scratch work up here. Okay? 3 months over 1 multiplied by my conversion factor, okay, over 1 year. Gets me, months will go away, gets me 3 over 12 equals my year. That's it. Now, if you didn't want to do the conversion like this, all you really need to understand, it's going to be 3 months out of 12 months. So that's the number that we're going to use. We're going to multiply this by 3 over 12. That's my time in years. It's 3/12 of a year. Now we can simplify this and actually change it to 1/4, and that's fine. I'm just not going to do that because I have a calculator. But 3/12. What if I happen to ask for 7 months? Well, I could do a conversion factor, but why waste my time when I can say 7 months is really 7/12 of a year? And I could do the same thing for so on, so on. What if I ask for 9 months? Well, that's 9/12 of a year, and etc., etc. Now, we've got it all settled up here. Now, let's go ahead and solve for A using a calculator. We want to work from the inside out. So, we're going to start with 0.05 and we're going to multiply it by 3/12. Now, notice what I did. I put my fraction as a decimal. So, if you got this type of calculator, this is the way you need to do it. You need to put your fraction inside your parentheses. I think I misspoke. I said decimal a while ago. I meant parentheses. So, always put your fraction inside of parentheses. So, I'm going to multiply that. So I've just multiplied the 0.05 times the 3/12. Now I'm going to add 1 because I'm following PEMDAS. Okay, please excuse my dear Aunt Sally. So I've just did everything inside of this little parentheses right here, and I've got 1.0125. Well, now all I have to do is multiply it by 2,000. And I get $2,025. So this student, after borrowing money for 3 months, he owes whoever he borrowed it from $2,025. Now, I do want to pause here for just a second before I move on. This little thing where I was talking about the 3/12 here, this is very reminiscent of a problem that was in section 7A. Remember in the last video, I believe it was, I told you that question 5 in your homework, that we would cover it in this video. Well, this question right here, question number 4, is very similar to it, okay? I'm not going to give you any more hint. The biggest hint that you need to understand is that you're going to have to find whatever fraction of a year that is. So be aware of that. And it's very similar to this. I think, though, that that particular one uses I as pretty, where this one is using your after money. All right, so just be aware of that. It's very similar because of the fraction you have to use. All right, 5. It says, use the formula for computing future value, and it even gives you the equation, and elementary algebra to find the missing quantity. Long story short, you got this, you're filling in the blanks, your job is to solve for it. So let's just go ahead and write all the blanks. Our after money, our future value is $1,620. Our principal is $1,350. times 1 plus my R times 4. Okay, so this is probably one of the best ways of solving it, is if you take this 1350 and you distribute it across this. So I'm going to rewrite this to say 1620 equals 1350 plus, well, 1350 times 4 gives me 5400 times R. Now, how did I go from this to this? Well, what I did is I did 1350 times 4 to get to 5400. And since they're multiplying, I just rearranged it. Instead of having the R in front, I put the R at the end. All right, so now what I'm going to do is I'm going to get rid of the 1350. And I'm by subtracting on both sides. So 1620 minus 1350 it gives us 27. And since I'm running out of room, I'm going to have to be a little bit smaller. So I'm subtracting 1350 from both sides. And I got 270 equals 5400 times R. Well, now I'm still trying to solve for R, so I'm going to divide by the 5400. So let's do that. Divide by 5400. And I get that my R is 0.05. But I need a percentage. So again, since I have to move my butt. So this becomes that R is 5%. All right. Now, the next thing that we want to talk about is the difference between what we call simple interest and compound interest. And I'll read this for you. Simple interest occurs as interest keeps adding to the principal, where compound interest occurs when interest is paid on the principal plus the previous earned interest. Well, what does that mean? Well, the best thing is to kind of give you an example. Let's go back to one of the very first things I told you. Let's say you borrowed $100 from me. This is the principal, okay? You're borrowing $100 from me, and I am going to give you a 10% interest rate, and it's going to be changing every week. So at the end of the first week, you borrowed $100 from me, but you have to pay me after 1 week, and if you don't, you owe me $110, okay? And the way you could calculate it is by really using this. I would say 100 times 1 plus 10% times 1, and it's going to give us this number, $110. However, at the end of week 2, you still haven't paid me, so you owe me 10% of the original principal. So you owe me $120. By the end of the third week, you owe me $130. By the end of the fourth week, you owe me excuse me, $140, and by the end of the fifth week you owe me $150. So basically each week you owe me an additional 10% off the principal. In this case happens to be $10. Compound interest is more complicated. All right, so at the end of the first week, it's you haven't had any problems, you didn't pay me back, you owe me $110. However, at the end of the second week, you owe me an additional 10% off of what you already owe me. What am I talking about? Well, let's find out what 10% of 110 is. Well, it's $11. So you owe me the 110 from the previous week plus an additional $11. So at the end of the week 2, you owe me $121. Week 3, I'm going to take 10% off of this. So 10% of 121 is $12.10. I'm going to add that to what you already owe me. So right now you owe me $133.10. So let's go to week 4. I am now going to find out 10% of what you currently owe me. And I'm going to add that to what you already do owe me. So at the end of the 4th week, you owe me $146.41. 5th week, same principle. I'm going to find 10% of this number of the money that you owe me, and I'm going to add it back to what you currently owe me. So at the end of the 5th week, you owe me $161, and I'll be nice, I'm going to round down, and 5 cents. This is the difference between simple and compound. Notice, simple just keeps adding 10% off of the original amount borrowed, where compound continues to add 10% off of what you owe me. So if you owe me 110, next week you owe me 121, then you owe me 133, then you owe me 146, 161, etc., etc. All right, so this is the main concept of how compound differs between simple. And knowing all this, we do some mathematical magic and we get some complicated equations. All right. These equations are very similar to your simple interest, because they use the same variables. A is after money, P is principal, R is rate, T is time in years. P is principal, A is after money, R is rate, T is time in years. The only difference the only thing that's new is the N. You have an N here, an N here in this particular one, and then the same thing here. The N is the number of times compounded. Well, what do I mean? Well, let's go back up here. Notice for a second. The number of times that I did my loan here was for 5 weeks, and it compounded weekly, so that my N for using this equation would be N is 5. It compounded 5 times, all right, because that's the way I set it up. However, and you don't have this in your notes, so I'm going to write this over to the side. Let's say you take a loan and it says that they're going to compound annually. Well, if it compounds annually, it means that N is equal to 1. If it says biannually, it means that N is equal to 2. If it says that they're going to compound quarterly, it means that N is equal to 4. Monthly, N is equal to 12. And then daily, N is equal to 365. Now, I'm going to kind of help you out on something. If you take a loan out from the bank, you not only want a low interest rate, but you also want the compounding to happen very rarely. In other words, if you don't want to owe the bank more money than necessary, you would rather compound the interest annually versus daily. You would owe a lot more money to the bank if it's compounding daily versus compounding biannually. That's the way I need you to understand this. The more it compounds, the more money you owe or you make. Alright, so let's go ahead and start explaining how this... Oh, by the way, I forgot to mention. Notice in this, I kind of told you how to work this problem. And I'll show you on the calculator here too in a moment. But for when you have a problem that requires this equation, and it's not the best thing to throw all these numbers in the calculator because your calculator may not know what you're telling it to do. It's best to do step by step. The first thing you want to do is to divide the R and the N. Then you're going to add the 1. Then you're going to raise it to this NT power, and then you're going to multiply it by the principal to finally get your answer. And then you would do the same concept over here, but notice in step 4 I kind of give you something, and I'll explain what this is when we get to this problem. But I'm going to walk you through how to do these equations. Alright, so let's do the very first problem. It says, compute future value using compound interest to determine the value of an account at the end of 8 years. If a principal amount of $2,500 is deposited in an account at an annual interest rate of 7% and the interest is compounded daily. All right, so we're going to use, it literally tells me what equation to use. Compound future value. Future value compound interest. Well, this is future value. Why? Because A means future value. So we're using this equation. We wouldn't use this one because this is computing your present value. All right, we'll see that in just a moment though. So I'm going to write that equation down. A is equal to my principal times 1 plus my rate divided by n to my nt power. All right, so let's plug in numbers. It tells me that I've got 8 years, and so I'm going to redo this. Let's find the principal first. My principal, here it goes. It says my principal is $2,500. So now we're going to find our rate. It says that my rate is 7%, so I'm going to put 0.07 because I have to move my butt. My n says that it's compounded daily. Since it's compounded daily, my n is going to be 365. And since I have another n here, this is going to be 365 as well. And then it says that my time in years happens to be 8. All right. So, in all truth and honesty, this is about as far on paper as you are going to be able to take it. You need to be able to put this in your calculator now. So this is where my little instructions to kind of help you out come into play. And I'm going to see if I can show these just a little bit better for you. Give me just a second. There we go. All right. So I had to rip that off. I want you to see that. All right. So we're going to be using this equation right here. So the first step is to divide my R by my N. So that's what I'm going to do. I'm going to go 0.07 divide by 365. Then it tells me to add 1, which is this step. So I'm going to add 1. All right. Now it tells me to raise to the NT power. Well, my NT was 365 times 8. So I'm going to go to my calculator. I'm going to find that little house top button. This is how I'm going to raise to a power. So I'm going to hit it. So it says ANS and it's raising it to a power. Now your calculator might be slightly different. Notice how mine kind of made a little small box up at the top. Your calculator may actually make a little caret or a house top shape, and that's okay. So just be aware that your calculator might be slightly different than mine. So I'm going to raise it to 365 times 8. All right. I'm going to hit enter, and I get some new number that means nothing to me. And now it tells me to multiply by my principal. So I'm going to multiply it by my principal. So this number does mean to me something to me. It's telling me that after 8 years, that my value on this account happens to be, and I'm going to round to the nearest penny this time, $4,376.45. So if I were to put money in the bank, if I had money to give the bank, that is, and I gave it to them at $2,500 and they had an interest rate of that, that means that after 8 years, this is how much money will be in that bank account. Now, I will go ahead and tell you that this interest rate does not exist anymore. Interest rates like this are non-existent on taking and on depositing money into the bank and trying to accumulate. It doesn't happen. Trust me, I know. All right, so that's pretty much it. If you know all these different variables, you plug it in, you follow the your PEMDAS, you divide, then you add, raise it to the power, and then multiply, you get your answer. It's pretty straightforward. There's really no guesswork in it as long as you can follow how to put this in your calculator. All right, so let's look at the next one. Ann and Tom want to establish a fund for their grandson's college education. What lump sum must they deposit at 6.3% annual interest rate compounded annually in order to have $50,000 at the fund at the end of the year? All right, so notice what it's asking for. It's saying, What lump sum must they deposit? Let's read that. So what it's asking for is what's the principal that they need to start with? And since we're using compound interest, we are going to be using this equation this time. We're trying to find their principal. So I'm going to write this equation down. My principal is equal to my after money divided by 1 plus R over N, all raised to the NT power. All right, so now let's go through this problem and start filling in our blanks. What's what? So my principal is equal to, well, we are wanting, Tom and Ann are wanting $50,000. So that's my after money. That's what they want to have for their child. All right, our grandson, excuse me. And I'm going to put in 1 plus, well, my rate happens to be 6.3, so I can say 0.063 divided by, this time it says compounded annually. Well, since it's compounding annually, my N happens to be 1. I'm going to close the parentheses off. And then it says that my time frame is 15. So my N is 1 times 15. All right, so I've filled on all the information. Now it's time to use the calculator to solve this thing. I've told you in your little notes here how to do that. The first thing that we're going to do is, I'm going to pull this over to the side just a little bit so you can see it better. It says divide the R minus, that should say N in your notes. I don't know why it says 2. It should say N. Sorry about that. So R divided by N, that's going to be 0.063 divided by 1. And then it says add 1. So I'm going to add 1. And then it tells me to raise to the NT power. So I'm going to do that housetop button again, and then I'm going to say 1 times 15. Well, we know that to be 15, but good enough for now. And so now we have this. Now, the next step's a little bit more trickier. It says A divide second, and then it gives you this little weird looking symbol thing. What I'm actually teaching you here is how to use the TI-84. We want to take this number that we just made, and we're going to try to divide it into the 50,000. So this is how we're going to do it. I'm going to put in my after money, which happens to be 50,000. Okay? And then I'm going to hit my divide button. So I'm going to press that button. And then it tells me to hit my second button. Well, here's my second button. It's the blue button. And then lastly, it gives you this weird looking symbol. What this is the negative button, and that is just below the 3. It's this button right here. So you would press it. Now, your calculator now says 50,000 divided by A and S. What's happening here? We have just told the calculator to take 50,000 and divide it by that 2.5 blah 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 that we came up with at the very beginning in these first 3 steps. So that's the point I really want you to know, is how to use this A and S button. This is going to save you a lot of time, because trying to type this number out, 50,000 divided by 2.5 blah 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 blah, that's a pain in the side. So it's easier just to use your A and S button. Alright, so hit enter. And it tells me that my principal is this, 19997.285 blah 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 blah. Alright, so this is telling me what in the calculator the exact amount of money that I'm supposed to do. However, we're not going to do that. We want to be able to do a little bit more. So the best thing for you to do, let's say I want this to the nearest dollar. Your instinct might be to round like this. That might be your instinct, to put $19,997 in it, okay? However, you would be wrong. This is not the answer you need to use. The reason being is because you didn't put in enough. The principal required is $19,997.28. You didn't put the 28 cent in. So what you really need to do in this particular problem is round up to nearest dollar. So the correct answer for this is actually 19,998. By putting this amount into the account, you are guaranteed to make sure that you are getting the desired $50,000. Now we can prove this by showing you a couple things, and I want to do this really quick. What if I only put in the 19,997? All right, so let's use this equation right here. I'm going to do this, and you don't have to do this. I just want to show you. I'm going to say my R and my N happen to be 0.63, 063 divided by 1 plus 1 raised to the 15th power, and I'm going to multiply that by that 19,997. Notice what I get. When I calculate future value using that $19,997, I don't make $50,000. I come pretty close. I'm only within just 70 some odd cents of it, and for most of us that's not a big deal. However, did I make $50,000? Did I actually make my goal? Well, technically no, I didn't. That's why you round up to the nearest dollar. You don't want to round down. All right, enough on that. Number 4. Sorry, moving around here. It says, upon the birth of their child, parents want to start a college fund by depositing money in an account that has annual interest rate of 3.6%. Compounded quarterly, how much must the parents now round it to the nearest $100 so that the child will have 60,000 at the age 18? So this is the same type of problem. We're trying to find the principal. So my principal is equal to, excuse me, my after money over 1 plus R divided by N, all raised to the NT power. Knowing this, I am going to plug in my information. My principal is equal to my after money. I want $60,000. All right, over 1 plus my rate happens to be 3.6%, so it's 0.036 divided by, it tells me that I'm compounding quarterly, so that's going to be 4. And it's going to be 4 here, and it's telling me that the child is being born and that we're wanting to give it to him when he's 18. So really what's happening here is 18 years have gone by. That should be self-explanatory. You start it when they're first born and you give it to them when they're 18, so 18 years old. All right, so now we're going to do the same thing. We're going to calculate principal, okay? Using this same setup. All right, first we're going to divide. So 0.036 divided by 4. I'm going to add my 1. I am going to raise that to my NT, which happens to be 4 times 18. And then I'm going to take 60,000. I'm going to hit the divide by button, second A and S, and that gives me this number, that the principal that I want to put in is 31476.56 blah 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 blah. Alright, now let's go back to the problem. It tells me that I need to round to the nearest $100. So my 100 is right here. This 7 tells the 4 to go up, and so I would actually have to put in $31,500. Now, just like in the previous problem, what would have happened if my answer, this is a if my answer was 3142.3 point blah 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 blah. If my answer happened to be this and I was still supposed to round this, I still would round this up, just exactly for the same reason. The money that's required is 423, but if I only give them this much, I didn't give them enough. So I need to make sure that I give them more than what I need. All right? And so that's pretty much everything about simple interest and compound interest in a nutshell. There's some problems I did not cover that are in your homework, but I hope that this gives you at least a good foundation. The hardest part about these problems is probably determine which one equation to use. I will tell you this, if the problem has the word simple interest, you are going to be using one of these two equations. Just that simple. It's your job to figure out which one. If it says that you are doing simple interest and you need to know the future value, well, that's your equation. If it's just as saying that you need to calculate simple interest, and that's just your equation. All right. The next thing is, if it tells you that you are doing compound interest and you need to know the future value, well, this is the equation for future value using compound interest. Okay. So if you need to, write that as future. And you can write this as principal, because that's what this one counts for, principal. All right, now one last thing and this video is done. Problem number 13 that is in your homework for section 8.1 is very similar to a problem that you've already done, which all the way back in section 5.1, which was the last module you just completed. I am not going to show you how to do this problem. I want you to try this problem on your own. It has nothing to do with compound interest the first part of it. It really doesn't. But it's very similar to this problem on question number 13 in 5.1. I do have a video about this problem, and it's for that reason why I'm not going to cover it again. So if you still don't understand what I'm talking about and how to do it, why don't you go back and watch the section 5.1 video. And go to minute marker 23:30. It's 23 minutes and 30 seconds. You should see the beginning of problem 13 about that time, and it should help you out with solving problem number 13. Alright, so I'm done with simple interest. The next thing that we're going to be doing is section 8.2, and that means that this module will be done. So I will see you in the next video. Bye.